Today we're looking at some more questions and problems on Taylor series and Maclaurin series. So the first question, they give us a function f, that f equals 2x over 1 plus x squared, and they want us to write the first non-zero terms in the general term of the Taylor series about x equals 0. Remember, when you see x equals 0, that's truthfully just the Maclaurin, so we can do it from our build. So we start with our 1 over 1 minus x, then we replace that x with a negative x squared to get plus on the bottom. And then I multiply the whole thing by 2x, making sure that I'm simplifying my general term as I go. All right, so I'm going to get 1 point for the first two terms, and then 1 point for the remaining terms, and 1 point for that general term cleaned up nicely. All right, the next question says, does the series in part A converge to f of 1 at x equals 1? And so basically I take that series that I got in part A, I replaced the x with the 1, and I simplified it to get negative 1 to the n times 2. So then I did a quick limit on that because I knew the limit did not exist because it's oscillating between negative 2 and 2. And that does not exist, does not equal 0. And so therefore this series diverges when x equals 1 by the divergence test. So for this, I'm just going to get 1 point for the answer, recognizing that it was not going to converge. All right, the next part says we know that the derivative of ln of 1 plus x squared is 2x over 1 plus x squared. We want the first four terms in the, they just want the first four terms for the Taylor series of ln of 1 plus x squared. All right, so basically they're telling us that if we integrate the 2x over 1 plus x squared, I should get my ln of 1 plus x squared back. So I'm going to integrate this. And I did it kind of fancy with x on my bound. You could have just integrated it straight up. And then I simplified my answer. And so I get 2 points for the first four terms, or two of the first four, and then a 1 point for the remaining term. All right, the next question says, use the series found in part C to find a rational number a such that the error is less than 1 over 100. Remember that notation is error. And so the first thing I wanted to figure out was this ln of 5/4. I didn't know why they were giving that to me. So I rewrote it into the form that looked more like my ln of 1 plus x squared. And so I said ln of 5/4 is ln of 1 plus 1/4, which is ln of 1 plus 1/2 squared. And so that told me that the x that they're referring to, or the x that they're talking about, is 1/2. All right, it's not 5/4, it's 1/2. All right, so from there, I started just listing out my terms. So I said like A1 is like 1/2 squared, which is 1/4, and then A2 was the negative 1/2 times x to the fourth, the negative 1/2 times 1/2 to the fourth, which is negative 1 over 32. That still wasn't less than 1 over 100, so I kept going. And I figured out that my A3, again, just plugging in or getting that third term of the series and plugging it in 1/2, I get that A sub 3 is 1 over 192, which is definitely less than 1 over 100. So that tells me that my error is happening at A3, which means that I use the first two terms to make my approximation. Remember, all series error, your error is the next term. So if my error is at A3, I use two terms to make the approximation. And so therefore my A would be the sum of the first two terms, which would be 1/2 squared minus 1/2 times 1/2 to the fourth. Simplifying that out, I get 7 over 32. Again, it's important to note that that 1 over 92 is my error because 1 over 192 is less than 1 over 100. All right, so I'm going to get 1 point if I knew to use x equals 1/2. I'm going to get another point for my value of a, so that's 7 over 32. And then my work, my justification, that I said that 1 over 192 had to be my error, so I used the first two terms for my approximation. All right, so the next question, we have f of x equals 6e to the negative x over 3. They want us to find the first four terms in the general term for f. And so I started with my known e to the x, and I replaced that x with negative x over 3, right? Simplified that out, and I got this nice little series. From there, I recognized that f was just this series times 6, so I literally just multiplied the entire series times 6 and simplified that out. I'm going to get 1 point for two terms being correct, 1 point for the remaining terms being correct, and then 1 point for the general term. All right, so the next one says, let g be the function given by g of x is the integral from 0 to x f of t. And they want the first four non-zero terms and the general term of the Taylor series about 0 again. All right, so basically what they're just asking us to do is integrate f of t. I did a little bit extra work on this one, but really they just wanted you to integrate f. And so that is essentially what I did. I literally just integrated my f and multiplied it by the 6 because I pulled that back out. All right, so doing that, you get this answer, this nice little series, and we get 1 point for the first two terms, 1 point for the remaining term, and 1 point for the general term. You may have done, something a little bit different. Like I said, my work is a little bit extra here, but the point was to integrate it and understand that when you integrate it, you get a plus c, and that plus c, that c is 0 because g of 0 is 0. All right, next question says the function h satisfies h of x equals k f prime of ax. And they want us to find the Taylor series for h. So the first thing I did was I noticed, or they gave us that h was like this series. And so the first thing I did was I found the derivative of f because they told us that h was k times the derivative of f. So I found the derivative of f, and I recognize that since f prime equals h, I set those two things equal to each other. So h equals that derivative times my k. All right, and then I also noticed that the h that they gave me is really just the series for e to the x. So since I have an equation for h, and I know h is really just e to the x, I could set those two things equal to each other. And then from there, I did kind of like a matchy thing. So like the exponent on the e on the left has to equal the exponent on the right. So that means the negative a over 3x has to equal x, or negative a over 3 has to equal 1. I also noticed that the coefficient on the left side, the negative 2k, had to equal the coefficient on the right side. So negative 2k equals 1. Solving for a and k, I get a equals negative 3 and k equals negative a half. All right, so I'm getting a point for computing k f prime of ax, recognizing that h was equal to e to the x, and finding values, or finding the actual values for a and for k.